Welcome to my talk about better code design. When I talk about code design, I mean classes and their interactions, not formatting and code styles. Now, this presentation will be mostly about the thought process that allows me to write code that is easy to read and to maintain. And there will also be plenty of code, but it doesn't mean that you should write your code exactly this way. This is more of a guideline to illustrate my thought process. Now, a little bit about me. My name is Filina. The dog picture that you see there is what you'll find if you look for me on social media, so don't worry about it. So I've been coding since '97. I've been working with PHP, Java, C#, a whole bunch of other languages. I'm a legacy archaeologist, which means that I dig into old code bases and I modernize them. I love test automation. I give talks, workshops. I have YouTube videos, and I own a company called Filina Consulting. A quick shameless plug, I'm currently available for projects. Call me. I live right about here. This is the French-speaking part of Canada, so I do speak French at home. That's where I am right now. Also, this is my 100th presentation. I started speaking in 2008, and it's been quite a ride. Thank you for that. Right, before we look at any code, let's look at how objects talk to each other. Now, this is probably a smell. What you have here is two-way communication. You have many points of contact. So the object calls the collaborator, and then the collaborator calls the object. It's not inherently wrong, but usually that makes code harder to test and to modify. So I would say it's better to only have one object aware of each other, not both ways. So the way we could change that with one-way references, we redesign the code so that the communication only flows one way. So any logic that the collaborator needed in the object is now going to be extracted from there and put into the collaborator. So now when we edit the object, we're not afraid of breaking the collaborator. And not just breaking it in terms of it's going to point to some like a method that doesn't exist. It's also about the state, right? Because let's say an object has a property and you change that property to something else, and then you call the collaborator and it's going to give you a different result because it relied on the object to provide some kind of logic, which means it's much harder to rely on the collaborator. It's much harder to keep that state in your head and figure out what's going on and predict what the collaborator is going to provide as a response. So by having this one-way reference just makes it easier to reason about what's going on under the hood. Now imagine that the object calls many methods on its collaborator, but those methods have to be done in a specific order. And I call this chatty. Now we need to remember to do this in the right order. Otherwise, we can make a mistake. So that's a lot of opportunity for a mistake. Also, if we change step one, in the second object, it could have an impact on the execution of step 2 and 3, right? So we can now start breaking things. So here's the question: why does the object need to be aware of that sequence? Why can't we give the collaborator everything it needs up front and let it do the entire task? Right. So imagine, like in human terms, imagine you have a collaborator at work and you know what needs to be done, but you only feed them one tiny little task at a time. And they just keep coming back. It's like, okay, I'm done. What's next? I mean, it is frustrating, right? And if you mess something up and you're going to do things in a certain order, where they're going to say, well, I can't really do this task because I don't have the information for it. So yeah, now you have to basically do most of the work. So that's not a great way to have a collaborator. So the less chatty approach is we modify the collaborator where all the steps are taken care of by the collaborator. And instead, the object only sends all the information up front for the collaborator to be able to do all of these steps without having to go back to the object. So it can convert it to private methods and expose one point of entry, or you can keep the 3 steps, but you can also split them into more steps. You can split them into 20, right? And all that without having to touch the object, right? So you also end up with this kind of encapsulation. And when I say task there, this refers to the human example, where you give it the full task, right? What is the end goal? And let them do their work. Now, I really need to mention buses. Now, I have nothing against buses in principle. It's just that very often they can add a huge level of complexity, and that's not necessarily bringing in any or sufficient benefits to justify that complexity, right? So you're just working for nothing. So once I spent 3 hours, tracking down a whole bunch of messages with the bus, only to end up with a message, the final message that nobody listened to. Right. So it was like a dead end. And I couldn't wrap my head around any of this. It was so hard. I had to draw a diagram basically. And then I had to schedule a meeting with the developer who wrote it to try and figure out what the heck is going on under the hood. And even they didn't quite understand it. So we had to draw a diagram together. Like, why would you write code where you need these complex diagrams, right? So it was basically a distributed mess, which is also something that I find quite frequently with microservices. Again, in principle, great thing, just depends where you need them. You might not need that extra complexity everywhere. So how do we keep things simpler? Well, we have to start with a design, right? Or rather, what drives your design? So I don't usually add complexity until I know that I need it, right? So I start as simple as possible. And because I start there, this instantly reduces my options, right? When I need to make a decision, because I just go, well, what is the least complex way to tackle this problem? And then I only add complexity as needed. Now, the second thing is, do I understand what's going on in terms of the business use case? So what does this code actually do? Not in technical terms, but in business terms. So let's say you calculate something like taxes on an invoice, right? So you want to send someone an invoice. You have products and services, and each line has, a tax, and some items might not be taxable. Now, what I want to see that in business terms in the code. I don't want to see a whole bunch of low-level data manipulation. So for example, this is very technical code, right? And I have no idea what's going on here. I don't understand how it's helping me accomplish, the tax calculation. It's almost like the tax calculation is an accidental side effect of all of this, because we fetch and then we filter and then we sort and we persist. And at no point does it even say the word tax. So each statement doesn't really mean anything. So I have no idea, like this is based on something I've seen recently. And it doesn't mean anything. So here I kind of need to know what a database schema is and how to properly construct the concatenated value of that. So I need to know the structure. I need to go into the repository and maybe even into the database and try to explore what's going on there. In the second statement, what is the significance of the two? Is that some kind of code? What are the other codes? What actually happens when I do that? No idea. So I would need to go and read in the filter class. Same with the sorter. Like we have integers. Well, first, what does integers true do? It's really not obvious. And what else can it be? Can it be integers, strings, arrays? Again, I have to go into the implementation of the sorter class to find that out, right? And also, why did we need to sort before persisting? No idea. Does it impact if I don't sort it? Does it have any impact? I mean, I'm not going to start commenting out lines and experimenting and put breakpoints to see what this code does. I'm supposed to be able to read it and understand it. This is not the case here. So that's going to be a pretty long day trying to figure this out. Now, I would say that we can talk about, design patterns all we want, but first we need to switch our language. We need to switch to, English or whatever your work language is, but the objects should speak business, right? Not technical. We shouldn't speak computer between ourselves. Code is written for developers. Yes, those are computer instructions, but that's also why we don't write with assembler. We write with a higher level language so that we as humans can understand what's going on. And so we should make it right in a way, make choices that reflect that as well. If it's just a sequence of statements that make no sense, like what I just showed you, then I might have to read 2,000 statements to have any idea what's going on, and start drawing diagrams just to be able to have a mental model of what's going on. Why not write something where the mental model is going to pop right into your head, right? So most code is written, that I've seen that people write is written for a computer, not really human. So let's make it human readable. Here's something that makes sense for my brain. On line 1, I get line items. So from the orders, I get line items by the pending order number. Okay, that makes sense. In the previous code, I would not have figured out that the list that we're getting is line items. So this is helpful. And then I calculate taxes for these line items. So the logic for taxes is entirely inside the taxes class. So if I need to understand that, I only need to go there, and I don't need to understand the entire order, right? I just know that I have line items represented in hopefully in a nice way. And then I have tax totals that are returned to me, which I can pretty much guess is the total for each tax, right? So maybe you can also split it by lines. But for example, you could say, well, here's the something you would stick at the bottom of the invoice. Here's the subtotal for all the items. Here's the tax, and here's the total, right? And the tax, like, so here in Quebec, we have two taxes. We have the provincial and the federal taxes, which are displayed separately on an invoice, always have to be. And so I would have those two taxes there in this tax totals variable. And I can persist it, with my order or display it at the bottom of an invoice. Moving on, so that was the warm-up. Now let's talk about the project. So we're going to work on a theoretical project, which is a marketplace for short-term rental. So think of it as a Airbnb, for example. So you can search for properties, which is apartments or houses for rent by city, the date and number of guests that you want to accommodate. And then you can reserve and pay, right? So this is a theoretical project we'll build, and we'll make decisions based on the business rules. So let's look first at an example of code that I very often see. For example, we have a reservation service, which has a reserve method. And then we have a payment manager with which we process the payment by passing some data. And then we get the payment back. And then we save that payment again with the payment manager. And then we save the reservation. And then we confirm the reservation. So confirm reservation with templating is going to give me HTML, which I then have to figure out what to do with. Like, do I display it? Is it partial? Is it a full page? Where do I put that HTML? And then that HTML also can be sent to the email manager as a confirmation, right? So the customer will receive an email saying, thank you for reserving this property for this date. You're good to travel. Well, we can agree it's not the worst design, right? But it's still way too technical for my taste. Let's unpack it. So this is the kind of design that happens when people think of objects in terms of database tables, right? Which I try not to do. I think of database tables at the very end inside my repositories. Now here we have process payment and save payment. Now we probably shouldn't be allowed to process a payment without saving it, right? So why are we splitting those two steps? Why don't we get the payment manager to do that all at once? Right. This goes back to the step 1, 2, 3. You have to know what the correct order is, because maybe we could have saved the payments like a pending payment without without being completed, and then once it's processed, then we update the payments, and maybe you have to call save twice. Who knows? I mean, it's not very clear. So the payment manager should have been able to handle all of that at once. Again, here we have an unnecessary separation of steps. Why are we managing different types of confirmations separately? What if we also want SMS reservation, SMS confirmations? it's not really ideal. And we have to deal with HTML inside of our reservation service class. Also, these class names are not great. I would say that whenever I see services and managers, I feel like they shouldn't exist, right? It's too generic. Might as well be a reservation thing, right? It just does too many things. It's unclear what the real role is. What I like to do is to go back to the business language and say, because a manager is in that context is a technical term. What I want is to have an action called make reservation, right? And we can read this in English. Make reservation. To make a reservation, I capture a charge with the payment processor, which then gives me back a payment confirmation. I then create a paid reservation, which I add to the reservation repository. And I also notify the buyer of that paid reservation. Oh, that's nice. Let's unpack it a bit. So make reservation, it does exactly one thing, makes the reservation. It doesn't certainly update the dates of the reservation later on. That would be a separate action. So we try to keep it small scope for each class. That's a personal preference. I just find that it yields classes that are easier to read, and you end up with fewer dependencies that may or may not be used with a given action. Then we capture the charge, right? Capturing is the correct term in this context, and it's something that anyone who deals with payments would be able to recognize, right? And the payment confirmation, once we capture, we get a payment confirmation. Now, the charge, notice that it's not pay for a reservation, it's capture a charge, because the make reservation class is going to distill all the information down to a charge, only down to whatever the minimal data that the payment processor cares about. So you put that in the charge, which is basically just an amount, and maybe like a limit how much time you can pay it, right? So like you can pay these $500 for the next 20 minutes. And then it becomes invalid, and a payment method, right? So like a credit card number, for example. And that is all what a charge is. And the payment processor has everything it needs to process the charge and give you back a payment confirmation, which then we can add it to a paid reservation. So the paid reservation here is a single object. So instead of having reservation and payment confirmation, we put it in one object, which I call paid reservation. So that then when I pass it as an argument, it's clearer how this data is connected. Otherwise, if you always split it into different arguments, you can end up with 12 arguments, and then it's kind of harder to keep track of what's going on. So it's harder to reason about when you have too many arguments. So I like to create these specialized objects for pretty much every interaction. After that, once we present things in this way, we also don't need to worry about the database tables. So the repository will figure out, what goes to which table. If it has to go to 10 different tables to persist it, that's not our job, right? That's not the job of the make reservation class. So we have this nice isolation going on. Now here, we don't want to figure out HTML. Make a reservation does not touch HTML. It just notifies the buyer, and it sends that to the reservation notifier, which can, send an email, send a push notification, SMS, and maybe also redirect the user to the confirmation on screen. So it gives us the flexibility to notify the buyer according to maybe their personal settings. So I would say that good design needs no diagrams, right? All the steps that we've seen are clear. Now the design is just for you to be able to follow along with the thought process. But normally, even a non-technical person should be able to see what's going on. So speaking of non-technical, my journey usually begins in English. So I would write out a scenario in Gherkin. So the scenario is a guest can make a reservation given I selected dates for property, search being a separate scenario. Given I selected dates for property, when I submit valid payment details, then I should receive a reservation confirmation via email. Right, so before a guest can make a reservation, they clearly need to provide, clearly need to have found the property and select some dates, right? And then they submit the payment details, and that is everything we need to know to be able to make a reservation, right? So the first step informs the amount that we are going to request. And when they submit the payment details, then they should receive a confirmation. So we're not talking about what is persisted where, that is an implementation detail. We only focus on the observable behavior, but that still kind of lines up pretty neatly with the previous diagram that we've looked at. So let's look at the search itself, and that is the part where we're gonna write some code. So we want to do a search for the properties. So we find we find a property if the city, guess, and dates match, right? So given the property LV44, so the LV44 is just a name I decide to give to it, so I can refer to it later in the same test. So it's like the name of the property for testing purposes. So given the property LV44 and the property is available on these dates, when I search for 2 adults on these dates, then I should see this property in the results. All right. So it's usually I would have other kinds of scenarios where maybe it's I search for a different city for which I don't have a property, or maybe the dates don't match, or maybe I have more guests than this property would allow, and so it will not show up in the search results. So it would be then I should see no results, for example. So I just keep going until I have a handful of use cases for the same feature. And then I'm going to write some code. But again, I'm going to postpone a whole bunch of decisions for later because I can. And I just want to grab that understanding and put it into code as quickly as possible. So I'm not going to worry about the framework, about designing the database. I'm not going to have to worry about the UI. I'm just going to code the business rules, right? I'm going to capture my knowledge at this moment in some code, and we can do that. So what do we know? Well, let's start. I like to start with the end, right? And just work my way to the beginning. So what does the user see? The user sees a number of results when they perform a specific search. Well, for me, this is an action. It's an HTTP request. So an HTTP request takes in some input and gives some output. This is roughly how I visualize it in my head. I don't actually use diagrams for that. So the search criteria comes in, response comes out, right? So how lean can I make the code? Well, we know what the output should be. Let's even not worry about the search component itself. Let's worry about just outputting some results. And I can literally just hard code that as an array. Do I need anything more? Not really. I mean, I even pre-formatted the price, so I don't have to write the price formatter. So this is 245 Canadian dollars because I would search from Canada. And so I know this is how I want the price displayed to the user right now. Maybe it will change later. And I will decide how to implement these details also at a later time. So just for now, it's a string. But let's go back to the diagram in our head. And so the middle part is handling a request and returns a response, which is a request handler. So I'm going to write a method called handle, which receives the request as an array and returns a response also as an array for now. Because I don't want to stop, and design all the classes. I just want to keep my thoughts flowing as quickly as possible so I can write it down. I don't want to write it down on paper and then have to transcribe it in code. I can just go straight to code. And I'm trying not to make too many decisions at once because I feel like for me, this is how bad design happens. I try to think of every little detail and then I lose sight of what I'm working on. So we probably need to put it into a class, give it some name. Apologies, lack of space, but final read-only class, which I really love in PHP 8. So I like to keep my handlers all separate, right? So one class per action, basically. It just makes more sense for me. To decide on the name, I actually went straight to the scenario, and when it says when I search for a property, and therefore it's a property search handler, right? So I extrapolate the name from the use case itself. And then it's much easier to later make the connection, what this part is responsible for. And for now, we return the same response regardless of the request. One step at a time, we'll do the search later. So yeah, we don't actually take the request into consideration, but it's still part of the arguments because we'll get to it. And then this is my index.php. I basically just parse the URL, do a quick match on the path. For now, we only have one, and then we output it as JSON. Later, we'll probably add, at the very least, some routing components, maybe even a framework. But for now, I just want something as simple as possible so that I can get to that response in the browser. I want to see something in the browser. I want to be able to demo it. I want to be able to have a conversation with maybe the front-end developers about it. So I capture every single bit of knowledge first. So then we can start even a built-in server. We don't even need Docker to get started. So if I have PHP installed on my machine, I'll just do that. And then I can go to localhost 8000 and I can see that. Great. And now we already have something that we can show to other people, and we can have conversations about it. And they're going to say, well, how do we want the price? Do we want to show something else in the search results, right? Do we want like ratings or something like that? Do we want a picture URL or something? So I really like this quote. A complex system that works is invariably found to have evolved from a simple system that worked. And I just push that idea to the extreme. I build code that works, then make the next decision and make it work better. And I just keep building on top of that. So I start simple and then I refactor, basically. Because I want to commit every 20 minutes or so. And at each stage, I have something that I can demo or I can show to someone, like another dev, and we can have a conversation. Moving on. Let's start converting those arrays to property classes. Now, property is like a search result, an individual search result. I call it property in terms of like a house or an apartment. I call it property because I feel like it's appropriate for the context. Because if I call it search result, maybe once we have multiple searches, I'm going to start being confused as to what it contains. So I have this property which I call a view model, right? So this is the view model, and each handler can have its own view. So for example, in other places, like on the detail of that property, I might have additional information like the address or the name of the owner, or maybe it's something that we only see when the property is reserved, but not when you're searching for it, because maybe it's private information that is only given once you have a relationship with the owner. So I don't try to create code that's too reusable up front, right? I would duplicate, for the detail page, I would probably duplicate the view and have like a detail view, a detailed property. And, once I have enough use cases, I will see whether I can reuse some parts, maybe use some composition. But I don't want to worry about it up front. I don't want to do premature reusability. So a concept to remember is too reusable becomes unusable. And you can feel free to quote me on that. I find that people are so afraid to repeat things that they create these clever designs that are later impossible to work with. So again, that property just has a name and a price. In PHP 8, super easy to write. Takes about 30 seconds. So if I have to throw this class away, I'm not going to feel sad about it because it cost me nothing to write it. Right, and then I go and I match. For now, I'm not going to do a database search. I'm just going to match, by the city name and return a whole bunch of different results. So I can then append something to the URL and then see different results. Right, I don't want to. I know that as I walk through the different use cases, I will discover things that might change how I want to persist data in the database. And therefore, if I commit too early to a database schema, I know I'm going to have to throw it away. So I don't want to do a whole bunch of work that I will invalidate after 5 minutes. So this is roughly the order in which I code. I start with a use case. I think about the input output, right? I think about the business rules that are involved. And then I worry about the infrastructure later, right? I capture my understanding of all the details that I discover in code. So of every time we have a conversation with other developers, they'll ask me, well, did you think of that? Did you think of that? Okay, let me code something. Right. So when I write business rules, such as, returning different results depending of city, if we don't fetch from a database, that's fine. I leave the infrastructure really for the absolute end. And this ensures that my business rules are also not mixed with the infrastructure because I code them at a separate time, which makes the business rules unit testable and just easier to read. Now, yeah, I'll just add the city to the URL, and it will give me something different, right? So now, we can do it through the URL. We can also have a JSON body in the request, where we could have maybe multiple search criteria. And it's a decision I can make, by creating a search criteria. Right. So the search criteria is going to extract information from the request. I can pass individual elements or the request as a whole, and the search criteria is going to figure out how to extract that so that when I decide to change the way the input is handled, I only need to change the search criteria, not the actual handler. Right. And so I create this. Basically, I slowly get rid of my arrays and replace them with classes that are kind of capture the logic more quickly, or better capture the logic. My rule of thumb is basically, can I walk a newly hired developer through my code without confusing them? And if so, it means that, other devs on the team, myself in 5-10 years, will still be able to read that code, right? So a request means nothing, but a search criteria has meaning when talking about searching. And we already know that it's going to contain a city as opposed to, we can basically expect it to always contain a city as opposed to some array somewhere. Yeah, so now again, a very simple read-only class. We can also validate the city and, throw exceptions, if the city is invalid. We can also add later other criteria such as the dates and how many guests. But for now, we're just going to match on criteria city. There's something I don't like though. So we have Lviv, we have Odessa, right? But there are many towns that can be close to each other, and searching just by city can limit my results. Because where I live, for example, it's an agglomeration of a whole bunch of small towns. So I can cross the street and end up in a different city name. So if I search by city name, I'm going to miss out on a whole bunch of places that are just across the street. So it would make more sense to search by coordinates on a map within a certain radius. So I could convert, for example, like an intermediate step where I would convert the city name to coordinates on a map, and then search by those. So for now, again, I'm lazy. I'm going to do by coordinates latitude, but eventually it's going to be a proper database search. But this is great because you see, we didn't write any queries, any database schema, and we already discovered something that is very useful, right? So when are we going to when are we going to get those coordinates? Are we going to do it like this, in a big array? Are we going to design a new table for storing coordinates? When are we going to fetch coordinates? Maybe at a time when when in the admin we add a property, maybe when we enter the address, it's going to automatically calculate the latitude, longitude, and store it along with the property. Great. So now it's good that we didn't design the schema up front, because we would have thrown a bunch of code away and wasted a lot of time. Which is what I mean when I say start by understanding the problem before solving it. Right. And now we look at this code. Great. We can put in a different city, and we get, even though we added those intermediate coordinates system, we can still get our results. No visible changes, but the code now captures the knowledge that we have about those coordinates. And so if two cities are nearby, we can get better results. Now let's fill in the blanks that we left earlier. So in this code, I'd like to separate the responsibility of searching the database from the responsibility of converting the coordinates, right? So for searching by coordinates, this is what a GeoSearch looks like in SQL. I'll explain this in a bit. I don't have a schema yet, but I already write the query so that this query could inform the design of the schema. So we have 2 points basically. So we're looking at distance between 2 points. One is our search criteria, and the other one is the longitude and latitude of the actual property in our database, right? Which is why we would probably need to persist it in advance, so we can then make the search. Okay, and then what we get back is a distance in kilometers, and we want it within a certain radius, and we can hard code it to, let's say, 2 kilometers, but we can also maybe allow the user to input the radius that they desire, right? Based on whether they plan to use public transit, or if they are going to rent a car, maybe the distance that they're willing to accept is going to be different, right? Yeah. So, and it's great because now we know that the search criteria that we planned is actually going to have one more element in it, not just the location, but also the radius. And then we can, again, hard code something, get a property repository going and find within radius, give it coordinates and give it a range. So remember we had a number 2 in one of the statements there that we didn't know what the meaning was. It's always good to convert those numbers into something that has into a constant, so that we can give it a proper name, so that when we read the code, we actually understand what's going on. I mean, in this case, wouldn't have been too bad, but still. Right. Another problem with cities is that we can just say Springfield, for example, and expect to get a single coordinate, because there are a whole bunch of Springfields, even one not far from where I live. So the third one near Saint-Hubert, Longueuil, that is near where I live. So that means that the user likely shouldn't be allowed to type in a city name, but instead search from a list before submitting the search. Right. So now we need another handler for the city search, where they would type the city, they will get some results, they will pick one of those, and the second action is going to search by the specific city, and then it will convert to coordinates for the purpose of the SQL query. So we're going to grab the search criteria from the request, because again, now we keep changing what the request format is. So let's just encapsulate that in the search criteria itself. So it's going to unpack the request any way it likes. So when that changes, we don't have to go and update every handler. Yeah, so in the past we submitted by city name, but now we need coordinates. So we need to somewhere be able to do that conversion. But the property repository is about searching properties, not converting coordinates, right? Maybe we're giving it too many responsibilities, right? So going back to our original diagram, how about, instead of returning names of city, just returning the names? With every name, we also already, the city search can already have the coordinates ready, so that when we select a city, we're actually inputting the coordinates into the search handler, which means now it doesn't have to be just a city. It could be a venue, for example. If I want to stay near a conference venue when I travel to an event, I can do that. So now we have coordinates, and then the validation doesn't have to be, is this a valid city name? No, it's just, is the longitude and latitude within a certain number, and that's it. Maybe you'll end up in the ocean, but that's beyond the point. At the very least, you can have this list automatically give you coordinates. So validation becomes easy. We can search by more things, which means that now basically we gave ourselves some free features without adding any extra complexity, right? So now we can search by specific venue or specific address and search within a radius of that. So now you see these correspond. So now we change the city to a set of coordinates instead. And then, of course, add the number of guests and the dates. But you get the point. And so we can pass the search criteria to the repository. The repository is going to grab those coordinates out of the search criteria, stick it into the parameters that we had in the SQL, and you get a list of properties that is returned. And so everything ties together pretty nicely, and you don't need any extra queries. So why do we spend so much time talking about all the use cases when talking about code design? Well, because code is nothing but a model of our business rules and knowledge. That's what it should be, right? It's not computer instructions, because a computer reads bytecode. We have high-level programming language. We can write things in English. So the code we're writing into IDE should be mostly driven by our understanding of the business rules, so that when we reread the code, we see the business rules, right? And so it takes a while, and it might take you a year, but once it truly clicks, I feel like your world will change, because mine has. At some point, it just clicked, and all code became way too easy. So yeah, designing the code becomes really easy, and the result becomes more maintainable. And that is all I have time for today. Hopefully I have time for a few questions. I'll put up these slides on social media shortly after the talk. And again, shameless plug, if you want your team to master these concepts, I offer pair programming, so don't hesitate to reach out, and thank you.
Hi, Anna. Thank you for your presentation. It was awesome. And I'm really sorry that you need to review this old legacy code. So, I understand that it really can be tough enough to understand what is going on. And just I'm curious, which tools you are using now to understand what is going on legacy project, and how you work with legacy, optimizing it, and doing better.
Well, since we only have 5 to 10 minutes, I will try to summarize that. But really, I use a combination of like technical tools, but also it's about the sort of the methodology. So I have to talk to people. Most of the information, because the legacy is often so technical, I have to go and find somebody who actually knows these things, right? Because the real information is not in the code, it's in someone's head. So I have to go around and ask people, what do they think the code does? And then I can compare whether it actually does the thing that they're hoping it does, which is there's rarely a match, right? So there's the expectation and there's the real code. But as I said, I also take the time to model things. So as I read, I take notes, and then I have read enough lines of code that I can start, drawing some arrows between boxes, and then I can start seeing what's going on. And this can be pretty tedious if the code is not designed in a way that I demonstrated. It doesn't have to be exactly like this, but what I mean is, if it's not written in a human readable form, then we have to go through the process of extracting that information manually. So I have to basically extract the design, and then I read the design um, to make sense of that. Automated tools are of little help because, I mean, other than, like, let's say in PHP Storm, other than control clicking through a method name and ending up in some more code, that's pretty much the extent of the tooling that I get. There's no tool that can really make sense of the code for me.
And
I
what
do write
about
tests as well.
Copilot? And what about Copilot, ChatGPT? If you're giving him you can give a lot of code files and just ask him to explain them.
I tried. I tried. So there was this tool in PHP Storm, and I mean, again, it's only as good as the code as you're reading, right? So it doesn't really know what the use cases are. It can explain, again, in technical terms, so it summarizes a method, a class, but it cannot tell you what actual use case all of this code is supporting, because that would be, the entire application, maybe, I don't know, 4 million lines of code. It really cannot tell, right?
Uh,
Um,
it's
so,
uh, in, it's interesting just to test. You know, uh,
well, I mean, I
I can
have,
say.
and the answers I got, maybe your code is different from mine, but the one I got wasn't very good. I mean, it was, as I said, it was decent enough that it could maybe summarize a class, but it couldn't really make sense because like, if you just pass, let's say in PHP, if you don't have any types, right? Because I demonstrated how you would create a class, then put the array into the class, and now the class has meaning, and then it's passed around, and you can run Psalm or something similar to see basically where the information flows. But when you have just anonymous data structures such as arrays, and you don't really know what they contain until you are at runtime, because maybe it grabs something from the database, um, and then it has to deserialize it, and I mean, so many things can be going on that you don't really have a clue. For example, I had an application where it was for some reason changing connections. Yeah. And I don't know, for some reason it was connecting to one database, and then midway it would just switch connection and connect somewhere else. And those databases are behind VPN, and the code cannot access, or the my application cannot access the schema. So most of the time, I
Mm,
don't even have the schema of the database.
Uh, and this is a good point. This is a good point because what do you think about not refactoring code, even not trying to understand it at all, but just going to business, ask what it should do, and just write another version of code, another version of services, repositories, and trying to replace old one by using a new ones which are good structured, described, and without any problems.
I mean, yeah, that's feasible. We get into a separate discussion now, rewrite versus refactor. And already refactoring can be high risk depending on the size and complexity, and how critical the application is. Um, so, I mean, I'm on a project that was supposed to be 6 months. It's now more than 13 months, and we don't know when we're going to have even a demo. I'm not in control of that project, so I only am a small cog in the machine. But the problem is that there are few people who actually know anything beside how they test it, right? So they have some testers who just click around, and those are the people who know the application best. So I find actually going to the testers is one of the best ways to understand what does the application actually do, right? Because they test certain scenarios. I can take those, I can automate them, and then so I write characterization tests based on what the QA team is doing. And when I say QA, I mean like mostly manual tests. So we automate those, and that gives us an idea. And it also allows us to start refactoring or rewriting while still maintaining those scenarios, right? So this gives us a path forward. But to rewrite a
Hmm.
whole thing, like, I don't know, I've seen things with like 300 microservices. To try and start rewriting that first to understand what each one does. I mean, it's not
Uh,
an easy task. It's a big
uh,
list.
I wasn't about writing everything, but just writing a small function and function by function, just replacing one case, two cases, three cases, and not
Yeah,
replacing refactoring the whole project, but just by
yeah,
small step by step, making
yeah.
it better because it's really, you never know what is covering under this array, what is going on under the hood.
Well,
Yeah,
but in
and
reality, replacing a single function or class might not be extremely useful because maybe that class should not exist or should be like split differently. And maybe this function doesn't really have a reason to exist. So one of the things I like to do first is to try and create those objects, for the information flow. So what is the message I'm sending from here to there, right? I want
mhm.
to, let's say, I want to make sure that an item that somebody just purchased is shipped to the customer, right? So that request is going to be sent to sort of the warehouse component or service. What would be the format of that? But I'm thinking in terms of the business use case, not in terms of what pieces of data it needs. And if I can start encapsulating the all this data in a way that a human would communicate also. So basically start replacing those bits and pieces of data with something that's human readable. And the same between functions and between classes. Just start, instead of having primitives everywhere, um, just start communicating with actual objects. And those objects will also validate your assumptions, because if you make sure that something is not blank, and then on some cases it is blank at runtime, then that's when you have you've discovered something.
Yeah, it's really interesting. Thank you for that response. And just have another tricky question for you. Just interesting opinion about legacy code, legacy systems. Which architecture is better, monolith or microservices? Where more spaghetti code and shitty code you can find, and which one is easier to maintain and refactor?
Well, I don't have a preference because it really depends on the size of the application, the teams. I mean, I think that most people who are using microservices could probably get away with just having a monolith, because if they can just restructure their code to be in isolated modules and verify that things are indeed isolated, then they can just go and slap an HTTP layer in between them, right? But until such time, just a well-structured project is actually quite maintainable, and you can make it so that people don't step on each other's toes. And I think that's actually even a first step before going to microservices, because what I've seen is people start designing microservices first before they even know the use cases, or know very little about the use cases. The problem with microservices is once you create a service, it's much harder to go back, right? So it's almost like a one way. And if you create it too small, or you create as we call them, seams, if you create the seam in the wrong place, it's actually worse, right? So
Yeah,
if you
totally
so
agree
as I
with you.
showed
Yeah.
in the beginning, the chatty one, where you go back and forth, I've seen that where you go to a microservice and it's really just a data provider, and it gives you some data and you still do some logic, and then you ask it for something again, next step, and just do this back and forth. You don't have a seam in the right place. So if you can start by designing classes where communication goes, mostly one way, and it will only circle back if it really needs to, but usually flows one way, very few communications, package all the data you need to pass to the next step, um, so that you can really keep things more isolated, and
Yeah,
try to
thank you
also
for that
pass as little
response.
data as possible. Yeah, if somebody needs a lot of data
Totally.
from someone else, then they're not isolated.
Yeah, totally agree with you. You need to understand what you're building before you actually build it. And just
Yeah.
also curious, I see that you are making a lot of code reviewing of old projects, legacy projects, and just curious, have you seen a lot of difference between code style of old versions like 4 or 5 version PHP and now? Is it getting better for now with all of these types and so on? Or even now, you can see a lot of legacy code, bad code, and PHP 8.
I mean, there's definitely a way to write bad code in PHP 8. It's a bit harder though, because in PHP 8, starting at PHP 8.0, the native PHP functions no longer accept as much garbage, right? So you don't do as much type juggling. So I'll give you an example that you could get away with in PHP 5. You could do a fopen, right, and pass it like undefined variable, right? So basically you give it null. And then what the fopen will do is, instead of failing, it's going to return false. And then you can feed that into fread, or whatever the next function is that you want, and you feed that, and if you feed again a bad input, it's going to continue returning false. So you have all these functions that at runtime, basically you start with garbage data and it just keeps passing false and false and false. And so you have all of this in execution for no reason. In PHP 8, it's going to fail at the first line. It's going to say, well, this is not a valid file name or file path. And it's just going to fail. It's going to stop there. So you cannot do as much type juggling and basically continue executing until the last possible moment. So it kind of fails early, so you don't really have a choice. If somebody's starting with PHP 8, is definitely going to write better code just because they don't have a choice. We took away some freedom.
Yeah,
Um,
yeah,
so
totally
yeah,
agree.
like
You're
what I see in PHP 4, for example, in PHP 4 and 5, is because of the type juggling, people don't really they just they accept that PHP allows that, and so they write code like that. So you could initialize a variable to a string, but then start interacting with it as though it was an array, and it will internally convert that into an array, and now it's an array, which is why static
uh,
analysis fails so badly. Because you're like, oh, it's a string, right? No, it's not a string.
oh, now we have a lot of tools like PHP, PHP linters, stance, psalms that can
Yeah,
statically analyze our code. Yeah, now it's far way easier just to
yeah.
write a good,
But you have to
really
know
good
about
code.
them. You have to know
Yeah,
about them,
and
because if you're a hobbyist getting into PHP, you don't work with a team. Nobody's going to tell you that Composer even exists, right? Hopefully, you'll stumble upon it. But I still see many people who don't use that, who aren't really aware of those, who also, some people who are aware of them but refuse because they're not ready to try, because they're convinced that it's not going to be helpful. Like I argue with people about unit tests all the time, well, or just automated tests in general all the time. So just because these tools exist and they're good doesn't mean that everybody's going to use them. But it does help, because as soon as people get into a team, get into a company where they're told these things and they're kind of molded to appreciate these things, right? Well, they end up appreciating them because they use them for real, not just as an experiment. And I think that really helps. So as the industry matures, I feel like people are put on the right track much more quickly.
yeah, just I'm curious how it can happen in business, in companies with legacy code, if they have enough money to hire good developer team. For me, really, it's obvious to use mostly everything you've said in practical world. So just using the same approach with SRP, one class for one function, small classes, a lot of classes, namings. I do really like that way. And I think that the main problem is not hiring good teams, trying to spend less money on good developers because um, for now, what do you think about it? How
Yeah.
does this
Well,
happen?
I don't think that money is always the problem because I know a company who can throw 1 million at a project and they still wouldn't hire the right developer because it's depending on how long the company existed. And legacy usually exists in companies that have been around for, at least 20 years, which means that there's a certain degree of complacency that maybe exists there, and so they're continuing to do what they've always done. The people who are currently there don't know how to make this code more modern. Like they wouldn't know how to get away from PHP 5, and so they call me. But when I arrive, I find that it's the problem is not just the code. The problem is often the whole organization, where you might have, for example, you might have a like, I don't know, security policies that are not well understood and they kind of get in the way, or it's very siloed, so the person who would know what to do isn't communicating with someone else, right, who actually needs uh, this advice. And let's say there is not a single senior developer. There could be a senior developer that ends up in a management role where they just have to attend meetings all day and they don't have time to help the team with anything. And also, these older, more bureaucratic companies tend to scare away the people who are most likely to help them, who are more like of the agile mindset, more senior developers. So
Yeah.
it's a half of it is a human problem.
Yeah, it's really a great point for you. Just thank you once again for your presentation, for your time, for sharing your thoughts.